Hello, my name is Benito and I will be going over my Java final presentation, where I will cover a variety of topics that have been assigned to me. So to me, the pillars of a Java program consist of a class and an object. A class is a user-defined blueprint or prototype from where objects come from. It represents the set of properties or methods that are common to all the objects inside of one type. So you have, let's say, species, and you have, a dog, a cat, etc., etc., etc. And for a class, like here, we have public class hello. It should be capitalized. So here we have examples of vehicles, animals, people, etc. And a class is essentially a grouping of things. So you want it to be the one that stands out the most, hence the capitalization. Now, going on to objects. An object is an entity with data unique to it or specific to it. It carries a name unique from all other objects to separate it from the rest. Because if you have multiple dog, 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 you're not going to know which one's dog 1, dog 2, dog 3, dog 4. Because you won't know that, oh, this dog that I wrote first was the corgi, or was the third one the corgi, you know? So they're usually lowercase to indicate that it's a smaller being, excuse me. Examples being Camaro, Cat 1, Cat 2, 3, and Corona. So here I have a graph which just shows what I just covered. We have dog as our main class, and we have multiple dog objects. We have dog 1, dog 2, dog 3, dog 4, and each of these have different, or they contain different information from the other dogs. So this one might be a German Shepherd that's 2 years old, that's brown. This one might be a Corgi, with it's 3, that's orange or something. You get the picture on that one. So here I have some actual code that's a little bit relevant to both the previous slide and this slide. So a member field is a member variable that belongs to a class. A public class player right here, we have a class with its contents. So this information exists inside of player. Here I have a code from a game that I started to make, just the very beginnings of a game, just a proof of concept, if you will. So before I go into that, I'm going to switch over to method. A method is a set of Java commands referred to by a name. So you're pretty much saving a series of commands under a keyword. So you're able to execute all the commands by using the name of that keyword, or the method. And they can take values as parameters and return a value as a result. So over here on the right, we have the preliminary information that led to this being possible. So we're asking the player to input a name that's being stored inside of n. Yeah. And then we have a set and a get, which is another thing for setters and getters, where we're just setting a blank slate, we're retrieving the user input, storing it inside of that n, and printing it out. And the same goes for the damage, where it'll prompt the user to enter their damage stat, and then they can enter damage stat, and it'll modify the value of D or of damage to a new modified value. So yeah, here we start off at damage 0 for both players. It prompts them to enter their name, and then it'll store the name, and it'll ask for their damage stat. Oh, it won't store the name. That's for a different program. But for this one, it just asks the damage stat, and then they just update it, store it, and yeah, that's just proof of how a method functions. Now, moving on to constructors. A constructor are used to initialize the object state. A constructor also contains a collection of statements or instructions that are executed at the time of an object's creation. So a constructor is pretty much like the groundworks of an object, where you can just call it and you just update it. So this is using the same images as the previous slide. So this just being the constructor, you're creating name equals n. This is just the method of storing information. And we also use that for damage in a way, yeah, for int damage. That was another version of that right there. So yeah, it's just for making the collection of statements. Now moving on to inheritance. When we want to create a class with information from an already existing class, we use extends, which would be this right here. So if we create an animal class as an example, we would make it store information like size, color, diet, and we could borrow that information and store it into specific animals, like a cat or a dog, an elephant, giraffe. So for this example that I created, I went with players and adventurers as my main units. So this right here is just the formatting and the outputting of the information that we got from over here. So we made the public class. The abstract class just makes it so that it's readily available, but we'll talk about that in a later slide. So we make the public class of adventurer, and we put in just two booleans just to check, just throw in some information to check. So we put public boolean is alive is true just to see if the player is alive. Public boolean is afflicted to see if they have any status conditions like poison, sleep, paralyzed. And just for the sake of this, we just set it to false. We have public void coins, which is just an update of or keeping track of the player's money. So for the sake of the example, we set the default to 0. Public abstract void is going to be used for a separate slide, but this is just separate information. So going on to the inheritance part of the whole point of this slide, we want to separate we want to retrieve the information that was established in the adventurer class. So we extend adventurer in player 1. So public class player 1 extends adventurer with the first, this one right here, player 1 being a child of adventurer because we're pulling information or inheriting, just like how you inherit certain traits from your parents when you're a baby or when you're being born. So we're just throwing in some separate information into player 1. So we have display name is just creating a method to be able to push out the name. Over right here, string name Steve the Warrior, which is just hard coded in, just for the sake of having a more detailed name instead of just Steve, Bob, Joe, Michael, just a title, the Warrior. So we have public void status, which is one of the things I have up here, or right here, the afflicted is alive. So we're using the method status with empty parameters to push out the information living status plus is alive. This is just to push out living status : true. This is just showing the user that the player is alive. And then we have another one, system out afflictions, and then also the current state of is afflicted. Since it's set to false, this will return to true and this one will return to false. Public void coins, we have the player's wallet, which is being updated to 10 coins in this instance, or inside of this extension. Sleeping is public void sleep is a separate thing for a different slide. But public class player 2 extends player 1. Now one of the things I found most interesting about inheritance is the same way that a family tree functions, where your grandparent will give details to the parent or your parent, and then your parent will give you things that you inherit, like facial features, for example. You can inherit all of the previous child's, now the parent class, all of their information. So we're just instead of having to rewrite public void status, coins, and sleep, we're just going to go ahead and just replace the name, and it's going to automatically know to display the name, to display everything else that we need to be displayed. Right here, the system outs. Public class player 2 will just be showing Legolas the Archer, which is over here on the right, and an updated wallet. So just for the sake of this example, I went ahead and set their wallets at a very big difference to be easily noticeable. So for Steve the Warrior, we have 10 coins in his wallet. He is alive and he is not under any afflictions or diseases. Afflictions is just a fancier word for that, for those that aren't aware. Legolas the Archer has 1,000 coins, is alive, and he is not afflicted by any diseases. Now moving on to overloading and overriding. Overloading occurs when two or more methods in the same class have the same method name but different parameters. So an overloading is a compile time concept. So for the sake of this, I'm going ahead and make an example adder, which is just adding multiple or different data types in different methods. So they're all public static void add, which is the same method, all the way through, but with different parameters. So for the first one, we're adding int a and int b. So there's two integers being added and stored into sum. And then it's being displayed. The sum of the numbers is whatever the numbers were. So moving on to the next one, we have public static void add double C double D. So this is just for doubles, like 1.3, 2.4, things like that, with things with decimals. And it's being stored into C and D. Originally, I wanted to do something a little more complicated, but this gets the point across pretty easily to beginners, I'd say. Public static void add string A, string B. This is just adding two strings together and combining them, or just pushing them together. So we have string A and string B. So over here we have, in the examples that I was covering, we have two integers, 3 and 4. They're being added up and pushed out as 7. We have add. This is how you call the function. You have the name of the class and then the name of the method and then the parameters. So we have 2.5, 3.6 for the doubles, pushes it out, 6.1. And then we have add ABC and DEF, just two separate strings separated by quotation marks and commas. Quotation marks are only for the strings. And then it just pushes them together. Overriding means having two methods with the same method name parameters, parent-child class relations. So over here, parent void mark, but they have overriding allows child class to provide a specific implementation of a method that's already provided in its parent class. So yeah, over here I have an example. It's just class dog, public void bark. It's present twice, but one is a child of dog, the hound. So it's using the same method of bark, but different parameters. Or yeah, this one's woofing, this one's bowling. Now moving on to interfaces. An interface is a blueprint that provides instructions and structure by specifying behaviors for other classes. So it's pretty much just setting the groundworks for the upcoming classes and making it just, I don't know. I feel interfaces are the most efficient way to this code in Java. Since Java does not support multiple inheritance in case of classes, but by using interface, it can achieve multiple inheritance. An interface is about capabilities like a player. Maybe an interface and any class implementing player must be able to implement move. So it specifies a set of methods the class has to implement. So over here, I made my name the object. I know, a little conceited, but I had to. So right here, the blueprint that I made is public interface human, just a general human. That could be, so I could have made it any other name. And I went ahead and just put some public string get name, public string get height, public string, just pulling information about the human to make it unique, or as unique as you can. Over here, I just went ahead and called in by doing public class my name, Benito, implements human. So we're just pulling in human over here, and we're implementing it. This is vital for an interface. And then it overrides public string get name all the way through, gets all the information, and auto creates the methods. And then I just have to put in return the information that I want to get. So I'll put my name, my height, and then my eye color, brown. So this all gets fed back to main and pushes out. I stored it in as Benito B, new Benito. I have to create the new one. And then it stores it in, and I just set up a little format for the output. So I have my name is, and then b dot the method, same for the height, same for the eye color, and then it pushes it out and just looks nice and pretty. It's, my name is Benito with a height of 6 feet tall and brown eyes. Moving on to abstract. So for abstract, data abstraction is pretty much the process of hiding certain information from code. So this is really useful for security. An abstract class serves as a superclass for other classes. Abstraction can be achieved when either abstract classes or interfaces, or with both. So an abstract class is pretty much a restricted class that cannot be used to create other objects. So to have access to it, you have to inherit that access from another class. Abstract method can only be used in an abstract class, and it does not have a body. So the information is fed to the method from the subclass. So over here we have the original parent class, but it's the one that I referenced to earlier that would be used in the later slide. Well, here we are. So we made it an abstract class just because it doesn't really negatively affect the other information, but it still gives us the access that we want to sleep. That's why sleep didn't show up on the other slide. It didn't have access to it. So we just created a blank state of public abstract void sleep with empty parameters. And then over here, we extended adventure, which is the parent class, and fed it right here the information that it needs. So you're just laying the groundwork. If it's left empty, it just ignores it. The user doesn't have to know everything that's in the code. So we're telling it the player 1 is sleeping. And the same is pushed onto player 2 because he's inheriting the state of player 1. So this just keeps the party united. So it's not like, oh, I'm going to sleep, but he's going to stay awake and do everything else. No, it's just a little bit of a workaround that I figured would be ideal to make sure players aren't going off and doing their own thing. So I just put a nice little story to it. You head to an inn and decide to head in for the night. You spend the night and wait. This would be showing what the player is doing. So player 1 is sleeping, and then it goes on to player 2, and the player 2 is sleeping. So yeah, it's just a nice little way of having that level of security to your code. So moving on to polymorphism. Polymorphism is, or something is polymorphic when it exists in many shapes or can change at will. So yeah, things that can change as it pleases. When it comes to Java, it allows you to define one interface and have multiple implementations for it. So going over here, we're going to go ahead and cover the wallet that I created for the game. So here we have the previous information that was already set up, but we have coins, which is also ignored earlier. So I set a default state of I have 0 coins, and then player 1 inherits the information of the parent class of adventure once again. And I have public void coins here with an updated wallet of 10 coins. So this is just text, not an item. And parent, or player 2, excuse me, once again inherited the player 1. I originally ran the code and I was a little confused. Why am I stuck at 10 coins? I was making a very simple mistake of of not going back and changing the wallet for player 2 the same way that I had to set the sleeping for player 2. I had to do the same thing for the wallet. So that might be something I could work on a later date to just make sure it's a little easier to manipulate for the developer. But yeah, I went ahead and set Legolas' wallet to 1,000 coins. And then over here on the right, we just have public static void adventure player 1, new player 1, and the same thing for player 2. We make a new player 2 to store the information. So I went ahead and created an array of players with just player 1 and player 2, and then it's just a little for loop. It's just adventure wallet, which is the item that we had, and then it's just the name of the array. It pushes it out, stores it, and it rolls through both players from over here, and then it just pushes out wallet.coins, which is the method that we have previously set for both classes. So when it does this, it'll show wallet 10 coins, wallet 1,000 coins. Yep, here it is. Yeah. Moving on to encapsulation. Encapsulation is defined as the wrapping up of data under a single unit. It is the mechanism that binds together code and the data manipulates. It can only be accessed through member function, or a member function of its own class in which it's declared. So it's like making little follow bunkers for data. So encapsulation is very, very focused on security in my eyes. So here we have just object set name, my name, and then my age that we set, and then just prints out username, user's age, get age. You think that's it. It's like, oh, that's a very simple program. Where's the encapsulation going on? Over here, we have public class encapsulate, which we just use to create an object over here. So we have this private information inside of a public class. It's like, oh, what's the point of having the private information there? Everything is public. The information is being accessed and fed into the public, not the other way around. So the users and anybody who would try to look into the code wouldn't find the private information because it's hidden away. So we have public int get age, and then it returns the private integer of age. This is already set from the behind the scenes. And we have the same thing for the name. So we have these hidden modifiers in the back, and then we have the public ones where it's just like, oh, it's just you're setting the age and updating it to whatever they put, which was stored into age 2, which is then stored into age. And the same thing is set for the name. So then this is just displayed as a very simple output of user's name, Benito, user's age, 22. This is very interesting to me, as I have a bit of an interest in cybersecurity, but yeah, this is encapsulation. So moving on to the code, I'm just going to go ahead and just show each part. Here I have my utility scanner, or import Java util scanner. I have it all set up as multiple mains because I felt this is ideal for showing the code. So going on to the first one, it's just the damage stat one. So I'm going to run it for proof of function. So we have player 1, please say your damage stat. It's currently 0. We have 25. Player 1's damage stat is not 25. Player 2, please say your damage stat. It's currently 0. This is player 2's damage, so I'm put 32. It is now 32. That's it. We stored the data. Here we go into player.java, the class that I'm using for this right here, for the player P1 and a P2. And it's just very simple. It's just string name, int damage, and then the constructor for storing the names, and then calling that over here for the methods, because we did this constructor for these methods. And then just set the name, get the name, set damage, get the damage. And that's a pretty simple program. So we just go ahead and comment this out for the sake of readability and management of the code. So the inheritance one would now be run. So I'm going to make this a little bigger. There we go. So we just have a nice little formatted Steve the Warrior, his wallet, his living status, affliction, same for Legolas. So yeah, it just pulls the information from Adventurer right here. This is the public class. This could have just be kept as public abstract and remove this, but I used the same code all the way through my list of tasks, and it worked in the end, so I was satisfied. So we have public class player 1 extends adventure. This is just the parent-child relationship I mentioned earlier. So storing this base information, the public void sleep isn't being accessed because it's an abstract from over here. Yep, right here. I still can't get over how useful it is. I just like it so much. Yeah, and then let player 2 will extend player 1, and it'll pull this information, and it'll just simply overwrite the wallet with Legolas's wallet, and then it shows this. So I can just do that, and then remove these, and then show overloading. So I covered this earlier as well. We have just the adder file that I have over here. So it's just adding an integer of A and an integer B, and double C, double D, string A, string B, and just combining the two. And we come back, and it's just 3 plus 4, 2.5 plus 3.6, ABC plus DEF. And it shows that. And then I can just do that. Very efficient, if I may say so myself. And then run this one. It just, my name is, get name, my name, or with a height of, get height, and then and colored eyes from get eye. I believe that's over here. Yep. Those are just the base methods, or the base variables. Oh, one of the things in an interface, I forgot to mention this earlier, in an interface all variables are treated by default as constants, and all methods are abstract. So the same way that this player, or what is it? Adventure here. Same way that this sleeps function works is also, that's the same ideology, I guess, is applied to this for interfaces. So if I were to put like, I don't know, like int I equals 3 or something, or 4 or 5, doesn't matter what, it would be treated as if I put constant equals 4, whatever, you know? That's just one thing to keep an eye out for. And the name, Benito, it's just calling the methods and then storing information in them. So I can go ahead and just close those up, the abstract. We have public static void. Yep, okay. This is just the condition that I set for the sleep. I believe that was this one right here. So I'm going to run it. And we have player 1 sleeping, player 2 sleeping. It's just going through and checking for this right here, for the public void sleep. And, you know, as I said previously, since it was inherited because I made an abstract, it was inherited by player 2 from player 1. And it's just, even though it's not in here written down, it's there, deep down in the code. So yeah, that function was intended. Nice little hidden bit of code. It'd be possible to feed just a bunch of information through another file to another program that you want to push out, which is pretty good layer security, I'd say. And then we have the wallets. It's the same concept, just pulling information and updating it into the void for coins. Yep. And then stores it into wallets, pushes it out. And then I just undo. And then we have encapsulation, which is my final topic. Okay, so encapsulation. Encapsulation provides layers to classes that are hidden from the user. So we start off with public static void main, same as any other, and we have the object of encapsulate and new encapsulate. So the same way that you would imagine a capsule, like a genuine medical capsule, it has like the powder inside, that would be our code. It's hidden away and tucked into a compartment. So here we're just setting the values into the variables. So we have set name is being set as Benito and the age is being set as 22. And then it's just pushing out the information. This would just look like a simple C in, C out from C++, but it's just another way of doing that, I guess. So we just have user's name, object get name, user's age, and then object get age. This doesn't look like it has many layers to it, but in reality it's like an onion. You have to peel it to get there. So the same way the human and my previous one functioned, where the information was stored away and hidden, the same way that an abstract treats the number variables as, or all variables, it treats them as constants and the methods as abstract, and is all tucked away and secure. You know, because all this information was just hidden, or it was transmitted directly. There was no chance for it to be taken away. The same logic would apply, or if not same, very similar, for encapsulation. It acts like a more complex and secure version of abstract, where we have the public class encapsulate, and it has access to only the public variables, right? That's the only way you could get this information that we have stored away, the private information. So I guess if you were making a database for a medical company, you would want every user's information to be private. You wouldn't want that stuff to be easily accessible from just going into the code. So we have private string name, private integer age, and then we have these public versions of the name and the age of the getters. All we're doing is storing the information that's originally private into a public variable. Because if we didn't do this, we would have no access to this. So then we're just overwriting it with the modified age and the modified name. Even if they're the same, the security logic still applies to where we had that extra hurdle to jump through to get to the code. So then this would just run. I'll do it once. So we just have user's name, Benito, age 22. Yeah, I can change it to something else, like 23. Yep, it runs correctly. So just a few last words. I want to say thank you to my professor for just taking the time to teach this course. So I know it was not an easy course, especially with the transition to online that we had. Yeah, it was tough, both to learn and both to comprehend fully. It's one thing to just spit out information, it's one thing to understand it. Yeah, if anybody else besides from a professor is watching this in the future, I definitely do recommend that you take a Java course at least once, even if it's just for fun. The language is interesting. Maybe not as much as another language like Python, which is more user friendly. Totally not advertising. Yeah, I enjoyed the course, and I hope that I can make some good projects with Java, and hopefully one day I can call back to my professor and say, hey, you taught me this, and you helped me. Thank you. So, once again, for finality's sake, thank you for your time, and may you have a good day.